Kia ora, and welcome to this explainer. Today, we are embarking on a truly mind-bending journey together. We're going to travel all the way from the absolute wildest sci-fi space dreams of warp drives directly into the hyper-realistic, brilliantly meticulous world of university physics labs. Seriously, we're taking a close look at exactly what happens when human ambition crashes headfirst into the cold, hard limits of science.
So, we really have to ask ourselves, can we actually break the laws of physics? If we ever want to cross the massive, unimaginable distances of space within a human lifetime, do we absolutely need to build a true warp drive, or are we forever bound by conventional science? Are we just trapped in our solar system, or is there some sneaky little loophole in the fabric of the universe just waiting for us to pull it?
Right, let's dive into this. To understand the dream here, we first need to understand the concept of propellantless propulsion. Now, traditional rockets work by throwing massive amounts of heavy fuel and fiery exhaust out the back to push the ship forward, right? So propellantless propulsion is essentially trying to move your car by sitting inside, grabbing the steering wheel, and pushing on the dashboard really hard to make it go forward. Using a bit of common sense, it sounds completely daft, but the payoff for space travel would be so incredibly enormous that science absolutely had to take a look.
Section 1. NASA explores the impossible, the Breakthrough Propulsion Physics Program.
Way back in 1996, NASA formally decided to explore these supposedly impossible concepts through an initiative called the Breakthrough Propulsion Physics Program. Led by aerospace engineer Mark Millis, they basically acted as the ultimate bouncers for physics. They systematically evaluated 14 different space drive concepts, officially separating 6 complete dead ends, like oscillation thrusters and certain gravity shielding claims, from 4 unresolved mysteries and 4 genuine avenues for future research into quantum vacuum energy and space-time modification.
And this whole era was absolutely packed with incredible mysteries stemming directly from university research projects. Take Dr. Ning Li's anti-gravity saga, for example. As a researcher at the University of Alabama in Huntsville, she published papers in '91 theorizing that a high-temperature superconductor could actually generate a gravity-reducing field. Her work got a lot of attention. By 2001, she had landed a nearly $450,000 grant from the Department of Defense. But then, she essentially vanished from the public eye. No results were ever published from that grant, and she sadly passed away in 2021, leaving behind literally one of the most intriguing, unconfirmed anti-gravity claims in the entire history of physics. Section 2. The EmDrive Controversy, a reactionless dream.
Now, if you think anti-gravity caught the public's attention, the EmDrive completely captured the world's imagination by outright defying the fundamental law of conservation of momentum. Its core claim was brilliantly simple, turning microwaves bouncing around inside a closed asymmetric copper cone directly into forward thrust. But logically speaking, a closed box of microwaves shouldn't move itself anywhere. It's exactly like trying to pull yourself up by your own shoelaces. It just doesn't work that way.
And this brilliantly illustrates why things got so crazy. Because in 2016, a peer-reviewed paper from NASA's EcoWorks laboratory reported measuring 1.2 millinewtons per kilowatt of apparent thrust from an EmDrive in a vacuum. The sci-fi world went into an absolute frenzy. We had numbers, we had thrust, we had a potential revolution on our hands.
Section 3. University labs uncover truths, the detectives of physics.
Okay, so this is exactly where those hyper-precise university research projects step in. When claims get wild, university labs act as the ultimate detectives of physics. The absolutely crucial point here is separating the wild claim from reality. Martin Tajmar's team at the Technical University of Dresden built an incredibly sensitive test stand using point suspension to completely isolate the EmDrive from all possible outside influences. And the reality they uncovered? The so-called thrust wasn't a physics-breaking miracle at all. It was literally just the metal test stand expanding and warping from the heat generated by the microwaves.
Which brings to mind this brilliant quote from Jeffrey Hengst, "In physics, you don't really know something until you observe it." This perfectly highlights exactly why this grueling, unglamorous university lab work is so incredibly vital. It is for sure the only true way to advance space propulsion. We can theorize all day long, but we really need the labs to observe the truth.
The TU Dresden investigations were incredibly thorough, too. They didn't just look at the EmDrive, they also evaluated the Mach effect thruster. By meticulously isolating these devices from external thermal and magnetic influences on high-precision balances in a vacuum, they completely disproved the EmDrive's thrust claims by 2021.
And let me tell you, even when an experiment completely fails to break physics, successfully eliminating false positives is a massive, massive win for science. It clears the path forward for everyone. Section 4. Does antimatter fall up? CERN's alpha experiment.
Speaking of reality, let's pivot to one final, absolutely beautiful physics mystery tackled by university consortiums: the gravitational behavior of antimatter. Let's keep it beautifully simple for a second. If you hold an anti-apple, an apple made entirely of antimatter, and let it go, does it fall up or does it fall down? Would it be repelled by Earth's gravity and float away into the sky, or would it crash to the ground just like a normal apple? Believe it or not, because the gravitational force is so incredibly weak compared to electromagnetism, this wasn't officially answered through direct observation until 2023. No way, right?
So, to figure this out, the Alpha collaboration at CERN's antimatter factory had to create antihydrogen atoms and confine them in a magnetic trap. Remember, if they touch normal matter, bam, they instantly annihilate. Computer simulations for normal matter in their Alpha-G setup predicted that when the magnetic trap was released, 80% of the atoms would exit the bottom due to the downward pull of gravity, and 20% would exit the top due to thermal energy. The big question was, what on earth would the antimatter do?
Well, in 2023, the historic discovery was finally announced. Antihydrogen is affected by gravity exactly like normal matter. It falls down. There is no passive antigravity. There are no floating apples. Just as Albert Einstein's theory of general relativity predicted over a century ago, gravity pulls it all down, keeping our feet firmly planted in reality.
So, we've seen today that the laws of physics are incredibly stubborn, and our university labs are brilliant at keeping us honest when our sci-fi dreams get a bit too wild. But it really begs the question, what other incredible propulsion secrets are still out there, hiding away in the quantum vacuum, just waiting to be discovered? Thank you so much for joining me for this explainer. If you are as fascinated by the mysteries of the universe as I am, check the link in my bio for more explainers. Catch you next time.